All right, so we're on part two, the inverse. It's the little half sheet that you got today. What we're going to do is review what is the inverse of an exponential function. In unit 2B, I'm sorry, we talked about this. We're just going to reiterate to make sure that we're all on the same page, okay? So our inverse is called natural log function. Do you all remember that? The inverse of E is natural log, okay? So if I have f of x equals e to the x. This is a table that we talked about in our notes on Tuesday. So on Tuesday, we came up with these values. We wrote the approximate value. Does anyone remember what I said approximately E is? Two point, anyone? 7, huh? 2.72. Yeah, right? You remember that? It's also in your notes from yesterday, in our other paper. Okay, so E is approximately 2.72. Okay. And so these are the values. Remember in our last unit, we talked inverse means that my X and my Y are switching. Yes. Inverse means the X and the Y values are switching. So this is my current exponential model. With exponential, currently we have a horizontal asymptote, which is our visible boundary line, right? We don't go past the X axis. Now, when we switch our X's and Y's, we create a new table. The new table looks like this. Okay. The opposite of a exponential is a log. And when you have log base E, that is called natural log. Okay. So the inverse of e to the x is natural log and vice versa. And all we did was switch our values of our table, right? Our x's and y's. So this is now the graph of that, correct? All right. And this time, instead of having a invisible boundary line horizontally, our invisible boundary line is now vertically at x equals 0 because we do not pass it, right? We stop at the y-axis. We don't go past the y-axis. All right. So do we see how they're affected and how that changes? Okay. So let's describe the domain of our natural log. So the domain of our natural log now, it has a starting point. It starts at 0, doesn't equal 0, but it starts at 0, and then it continues to positive infinity, right? Because it's going forever to the right. Our range goes forever down, which is negative infinity, and forever up, which is positive infinity. And if you look at our notes from Tuesday, that is the opposite of the exponential. For the exponential, you can see it goes forever to the left and forever to the right. However, it starts at 0 on the y and goes up to infinity. All right, how do you feel about natural log? Do we see their relationship? Why is this important algebraically? What does that mean I can do with them? Anyone? Anyone? Because they're inverse functions, that means they're inverse operations. Okay. So I can use them to isolate variables to cancel each other out in order to get my variable by itself or a number by itself. Does that make sense? All right. So we're going to talk about the log transformation, natural log transformation rule. As you can see, we still pretty much have an A, a C, and a D. How it looks is what changes. So now we have f of x equals A times natural log of x minus c plus d. We still have our A, our C, and our D, and they still have the same roles. Does that make sense? D is still my vertical translation. So this is still vertical, meaning that if D is positive, my function is moving up. If D is negative, then my function is moving down because D affects your y-axis. Okay. Your C, remember again, our X's are, okay. So even though we think it's negative, this is actually a positive C. It's going to look like a negative C, but it's actually a positive C, which is why it's going to move to the right. And if it said plus C, it's actually negative, and it's going to shift to the left. And this is our horizontal translation. Okay? Your C is also your vertical asymptote. If I can spell, that would be great. Let's try that again. Vertical asymptote. And it's going to be whatever your C is. Okay? Last is our A. Our A transformation variable. It's going to tell us whether we stretch or compress, and if we are a reflection. The key thing to pay attention to is the absolute value. So to determine whether it's a stretch or compression, you're taking the absolute value of that A, okay? Meaning that it being negative or positive has nothing to do with it. It's just talking about absolute value, what is distance from zero. If it's greater than 1, then I'm stretching vertically, okay? Think about, I'm going to go to the gym, I'm going to work out more, I'm going to get skinnier, right? Now, what if I cut my workout time in half? It's going to get compressed. It's going to get wider. It's going to start shrinking, right? Those are going to compress, okay? So the last thing is if your A is negative. So if A is negative, that's what A is less than 0 means. So if A is negative, then that's a reflection across the x-axis, okay? All right, so at the bottom of your notes, you should have a little white space. Yes, I did that right? Okay, and that's what we're going to write in our example. So our example that we're writing in is -2 natural log of x minus 3 minus 5. I should have wrote f of x. I'm sorry. I'm going to squeeze that in there. So this is our function. From this function, I want you to identify the A, the C, and the D, and describe in words what does that mean transformation-wise. Is the function from the parent function, is it going up, down, left, right? Is it stretching, compressing? Is it reflecting? Okay, so step 1, we identified our A, our C, and our D, and then we're going to describe what does it mean is happening to this function. Okay, and go. Okay, so for this problem, our A is our factor in the front. What are we multiplying by? And that is -2, right? All right. Our C is with our X. What are we adding or subtracting to our X? And remember that it is a liar. So if it looks like a negative, it's actually a positive. Okay. Remember, this means C is greater than 0. So if it looks like minus C, it's actually a positive C. And our D is what we are adding and subtracting outside away from X. That's because it's affecting our Y's, and that would be -5. Okay, so now that we've identified, we're going to describe what each piece means. So because A is negative, what do we know that means? Reflection over the x-axis. So our first transformation we know is a reflection over x-axis. Okay, because the absolute value of A is greater than 1, that means that it is a vertical stretch. By 2. Okay, so A is done. Now from C. C is 3. It's positive. So because C is a positive number, that means that it goes 3 units to the right. And then D is -5. Because D is negative, that means it's going to go down. So we went 5 units down. And that's how you read a transformation. It wasn't terrible, and you know it. You wanted it to be. Okay, now that you've seen it and you've checked yourself, how do we feel about it? Did you identify the A, the C, and D, and then describe what each piece does? All right, awesome. Okay, so we are done with part 2.